Okay, let's just do a couple of these from this table. I guess we can do number one. So h prime at 1. Oh, look at that. I've got a product of functions. Both of those have x. So h prime of x will be derivative of the first. Derivative of x is just 1 times the second plus derivative of the second times the first. And that's just derivative of this guy. Plus. Now, yeah, this is a product, but that first function is just a constant. The derivative of a constant is 0. You don't have to use product rule when one of your functions is just a constant. The constant just comes along for the ride. The derivative of 4 times g is just 4 times the derivative of g. Now we can plug 1 into everybody. So h prime at 1 will be 1 times f of 1 plus f prime at 1 times, now I'm plugging in a 1 for that x right there, plus 4 times g prime at 1. So we're going to have to look a bunch of these up in the table. F of 1 is 3. F prime at 1 is negative 1. And then 4 times g prime at 1, like that's right there, another 4. So what do we get? We get 3 minus 1 plus 16. So I think that's 19 minus 1. Definitely check my arithmetic here, but I think we get 18. Okay, now we want h prime at 2. So I've got a product of functions. I'm going to need the product rule. H prime of x will be f prime g plus g prime f. So then at the value 2, this will be, I'll write these all out explicitly. F prime when x equals 2 times regular old g at 2 plus g prime at 2 times regular old f at 2. F prime of 2, that's 7. G of 2, regular old g of 2 is 3. G prime at 2, right there, that's 1. And then regular old f at 2 is 5. So 21 plus 5, I think we get 26. Okay, h prime at 4. We're going to have to do a little thinking here. We're going to have to actually take a derivative. So h of x is 1 over x plus g over f. I'm going to have to find the derivative of 1 over x. So let's just consider this guy right here by himself for a minute. I'm going to do this 2 different ways. I could do this using quotient rule. The derivative of the top, the derivative of a constant is just 0, times the bottom, minus the derivative of the bottom, derivative of x is 1, times the top, all over the bottom squared. 0 times anything is 0. I just get negative 1 over x squared. That's using quotient rule. I'm going to do the same problem using power rule. I'm going to say 1 over x, I could rewrite as x to the negative 1 power. Then the derivative, x to the negative 1 derivative, just power rule here. The negative 1 comes out front. And now I want to take that negative 1 and subtract 1. Remember, the power goes down by 1. That's negative 1 times x to the negative 2. Oh, that's the same thing I just got. That's negative 1 over x squared. Okay, I needed that, but now we have that in our pocket. We can use that forever now. In fact, that guy's going to come up a lot. The derivative of 1 over x is negative 1 over x squared. So negative 1 over x squared. I did his derivative. Now I got to do quotient rule here. Forget about f and g. If you get caught up on f and g, you're going to get really confused on a problem like this because the f and g are in different places. When it comes to quotient rule, think derivative of the top times the bottom minus derivative of the bottom times the top all over the bottom squared. See, now f is the bottom function. Okay, so h prime of 4 would be negative 1 over 4 squared, because that's my x value, plus g prime at 4 times regular old f at 4 minus f prime at 4 times regular old g at 4 all over f at 4, just this part over f at 4, whatever that number is, squared. All right, so now we're going to find all those. So that's just a negative 1/16 there. G prime at 4 is 9. Regular f at 4 is 0. Minus f prime at 4, negative 3. Regular g at 4, 6. Over f at 4, squared. Hold on, let me pause. Yeah, I had to pause and make sure I copied everything down right. We get 0 in a denominator. We wrote everything out right. Nothing is wrong here. But then this is undefined. There's no answer here. This is undefined. You can't divide by 0. And it's undefined right there because of that. Otherwise, we would just keep simplifying and get an answer. Okay, that's a good place to stop.